All right, good morning, guys. This is 7.8 geometric sequences, and the objective is to write and use recursive formulas for geometric sequences. Okay, so the big thing from this page is in a geometric sequence, you have that's called a common ratio. And I'll explain more on the next page, but actually this sentence right here sums it up very well. Two sentences. Every geometric sequence has a starting value and a common ratio, and that's going to look really similar from the last section that we did with exponential growth and exponential decay. Right, and what I would do for your notes though would be to put just this first sentence written right here. There we go. Okay, so just first an explanation again what geometric sequence is. It's a pattern that involves multiplication, not addition or subtraction. That would be arithmetic. So which of the following are geometric sequences? Well, if you can figure out the pattern by using addition or multiplication, that'll let you know if it's geometric or not. So this would be a times by 10, and that holds true with all of these here. So this would be, yes, this is geometric because of the multiplication. Now this one you can see you have to add 2. So this would be a no, this is arithmetic. And then this one right here, kind of a tricky one. You would multiply by -1, multiply by -1. So this would be a yes. Okay. Just a little bit more of the same here. Are they geometric? And then the second part is it arithmetic? So the first one here, you have a multiplier by 2, so this is definitely geometric. And then letter B, this one would be addition, which would be arithmetic. This would be add by 3. Okay, this goes into your notes. This is a pretty important part here. Now this is explicit formula. We've done this in the past. I know the title or the objective talks about recursive. We're going to focus mainly on explicit formula because it is a little bit more useful when you're finding a term from the sequence. So go ahead and put this into your notes here. And then just a reminder, guys, geometric means there is a multiplication pattern. Arithmetic means there is an addition pattern. The A stands for your initial amount. A1 right here, that's your initial amount. Okay, and then your R value is your common ratio. That's right there. This is your initial amount again for your A1. Sorry, it's so sloppy here. And then your D value is your common difference. So ratio deals with multiplication. Difference means how much you have to add to get to the next number. Common difference for that one. Okay. All right, so here we go. Definitely put this one here into your notes, except we are just going to find the explicit formula for the sequence 7, 21, 63, and 169. 189. So then for the first one there, we find out between 7 to 21, we times by 3. 21, 63 times by 3. Everything is times by 3. Okay, this is geometric because it has the time symbol on it. So here's what we need. The formula is AN equals, we need the initial amount of 7. We're going to times that by our common ratio of 3, and we're going to raise it to the n minus 1 power. And it is that fast, guys. Yeah, that's it. Now, the nice thing about this, if you want to check your answer to see if you're right, so 7's our first term, right? So take the number 1, put it in place of n. So it look like this, 7 times 3. If we're going to find the first term, we put 1 in place of the n. Well, 1 minus 1 is 0, so we're taking 7 times 3 raised to the 0 power. Anything to the 0 power is 1, so your final answer is 7, right? All right, so if we're finding the first term, this is a 7. And if you want to check the third term, we do the same thing, except we put 3 in place of the n. So let's give that a shot. Okay, so we should get 63 when we're done with this one. So 7 times 3. If we're finding the third term, we put 3 in place of the n. So 3 minus 1 is 2. 7 times 3 raised to the second power. 7 times 9, 63. See how that is the third term. All right, so it's handy if you want to find like the 30th term. You know, you'd put 30 in there in place of n, and then you could find the answer quickly. All right, so find the recursive and explicit, but we're just finding the explicit. So our first term is 2. Our common ratio is times 2, because to get from 2 to 4 and 4 to 8 times 2 to the n minus 1 power. Sorry, I forgot the an up front. There it is. Okay, this is a good one. If it's going down, that means you are multiplying by a fraction, and in this case, it's getting half as big. So our starting number is 40. The common ratio is 1/2, because it's like same thing as dividing by 2 is the same thing as multiplying by 1/2, and then to the n minus 1 power. Okay, and then this is just checking to see if it's arithmetic or if it's geometric. So again, you would check this, and this one, and this one. Okay, this one is definitely subtracting 8. Subtracting 8. And then to see if there is a pattern here, what you'd want to do is you'd want to divide the previous term. This is a better way to say it. Taking 51 divided by 60, and I get 0.85. So now I'm going to take 43.35 divided by 51. So I'm taking the number divided by the previous number. When you do that, you get 0.85. Okay, so that means to get to the next number, you would have to have times by 0.85. Versus this one you'd add a -8. So this one here is arithmetic. This one here is geometric. All right, to get your explicit formula for each sequence, you would start with your initial number times your common difference, common ratio to the n minus 1 power. All right. For arithmetic, give your starting number plus n minus 1 times your common difference. In this case, it is -8. Okay. And you want to find the price of each item after the 6th markdown. And I know you probably could have just used patterns and then find the next number, but the object is, you know, let's say this number was bigger than 6, right? Let's say this was like 15 or 32, you know. Instead of writing all those out, you could plug now 6 into the place of the number n and find out what those answers are. Okay, and then if you, for this one, you'd put raise it to the 6 minus 1 power, and then you'd get your answer for that one. And this next one, you'd run that through the calculator, and then you get your answers. Okay. Again, we are not doing recursive. We're just doing explicit for this one here. If you aren't quite sure what the multiplier is, just take a number divided by the previous number. So take 84 divided by 14. And I get 6. And then just make sure that you check 504 divided by 84. And I got 6. So that's an easy way to find what the multiplier is. So 324 divided by 648 for this one right here, you'd end up getting 1/2. The multiplier is 1/2. So both of these are geometric. And then you could write your formulas for those. Okay, and then this definitely should go into your notes, but it's surprising how fast this one is. The initial value is 6. Common ratio is 2. Raised to the n minus 1 power. All right, so when you set up your table here, it's going to look a little different. Usually it's x and y. In this case, it's n, and then it's a to the n. And our good numbers to put in place of n are, again, -1, 0, 1, and 2. So I'll start with 1, because if you put 1 in there, you'd have 6 times 2, 1 minus 1. This one's pretty easy to solve for. 6 times 2 raised to the 0 power. Adding the 0 power is 1, so your answer is 6. That one's pretty quick. I'll do the same thing, except we'll put 2 in place there. So now we'll have 2 minus 1. 2 minus 1 is 1. And that would give us 12. And then we could put 0 in there. So we'd have 6 times 2 to the -1 power. That drops to the bottom, so it'd be the same thing as 6 on top, 2 on bottom. 6 over 2 is 3. And you kind of see the trend here. It goes, the pattern is 12, 6, 3. Everything's cut in half. 3 cut in half is 1.5. And then we go to the graph, and this is just going to be a really rough sketch here. To the left one, up 1.5. Left and right, 0, up 3. Okay, so you kind of see those two dots. Now it's going to get a little bit messy here because I'm not going to be able to go up to 12. But you go to the right one, up 6. Let's see here. Yikes. 4, 5, 6. There. You can see how the graph is starting to curve up like crazy. And then that would be your graph down there, an exponential graph. Okay, we can skip this one. I already did it. And this is what the homework assignment looks like for today, guys. If you have any questions, come and see me. If not, have a great day.